So in this video, I'm going to go over investigation 4C, hopefully within 10 minutes. So let's take a look at some problems. We've learned, the first thing we've learned in this chapter was substitution. So let's take a look at some problems. For example, let's say we have y equals 6x minus 7 and y equals negative 2x minus 9. So these are two lines. Slope is 6 and this one, the slope is negative 2. But these two lines will intersect somewhere. When it intersects, these two y will be the same. Therefore, we can substitute this y with this guy, because these two are the same, So we're gonna set up 6x minus 7 equals negative 2x minus 9, and using basic moves of solving equation, we're gonna get rid of 1x from one side, so that we have 8x minus 7 equals negative 9, and add 7 to both sides. So we have 8x equals negative 2, which is negative 2 over 8, or negative 1 over 4. So now we know that x equals negative 1/4. Therefore, this x and this x is negative 1/4. So we can substitute that using either way. I would use this one. So we have y equals negative 2x. Now we know x is negative 1/4 minus 9. So here we have y equals negative times negative right here. That gives us positive. So it's positive 2 over 4 minus 9, which is 1/2 minus 9. So y equals negative 8.5. So that's going to be y. So that's the answer. So that's how you solve system of equation with substitution. Second key point is two lines are parallel. Then if two distinct lines are parallel, then those never intersect. On the other hand, if that slope is different, then those two lines will intersect somewhere. So let's take a look at the example. So let's say we have y equals 3x minus 9. And also let's say we have y minus 3 equals 3 times x plus 4. And let's say we have y minus 3x equals negative 9. And let's say we have 2x minus 3y equals 6. Okay? So we can tell these two lines, so we have 4 lines, 1, 2, 3, 4. We can tell these two lines, the top two lines are parallel lines because we have same slope. If the slope is the same, those are parallel, as long as those two lines are distinct. If those two lines equal exactly the same, that's exactly the same line, so it intersects as long as the line goes, so there's infinitely many lines. The problem of last two equations is really these two are not really helpful, because we can really tell what the slope is right away at a first glance. So the first two lines here and here, we can tell the slope right away, but these two are not really, we can't tell for the bottom line. So we're going to change this into the form that is helpful to us. So we'll add 3x to both sides so that it looks like y equals 3x minus 9. So now we can tell 3 is the slope. But I want you to realize that this is exactly the same as the first line. So these two are exactly the same, so it's identical. The point is you have to solve this equation into the form of y equals, we're going to have to change that so that we can tell what the slope is. This is not the slope, so we got to change that. So the second one, so fourth equation, this is not helpful form, so we're going to have to change it into the form like this so that we can tell the slope at a first glance. So let's use basic moves to solve the equation. The same deal, same business, just like we have numbers. So cancel that out, so we have negative 3y equals negative 2x plus 6. One more step, we got to get rid of this negative 3. So divided by negative 3, divide this by negative 3, divide this by negative 3. So we have y equals negative divided by negative is positive, so we have 2 over 3x plus negative 2, which is simply negative 2 because adding negative is the same as just a simple subtraction problem. So now we can tell what the slope is. Slope is 2 over 3, which means 2 up and 3 to the right. So this is not the same slope. So as this one or this one. So this line will intersect somewhere at exactly 1 point with this line, and also this line will intersect at 1 point, exactly 1 point. There is no way that you can the straight line can intersect with more than 1 point as long as we are talking about two-dimensional. Okay, let's move how to solve solving equation with elimination. So let's say we have 2x plus 3y equals 1, and also say we have 4x minus 2y equals 10. Now if it's a simple elimination problem, we can either add or subtract, but if you add these two, we'll have 6x, and if we add these two, we'll have 1y, and the right side will be 11. So it's not going to be really helpful because we are not eliminating any of the variables. If we're subtracting, we'll have negative 2x and also 5y, because 3 minus negative 2 will be 5y, and negative 2. Again, we are not eliminating any of them. So we're going to have to change the form so that it's more helpful to us. So one thing we can do is, let me change the color, is we multiply the first equation by 2 so that we have 4x plus 6y equals 2. Now this form is really helpful because if we subtract, then we can eliminate x and we just can focus on what the y is. So let's eliminate that. Let's subtract. Make sure you use parentheses so that reminds you of you're subtracting each column, not just the first one, but all of them. So subtract 4x minus 4x is 0. We don't even have to write that. Negative 2 minus positive 6 is negative 8y equals 12 minus 2 is 8. Dividing both sides by negative 8, we'll have y equals 1. So now we know this y is 1, this y is 1, and this y is 1. All the y we have in this problem is now it's 1. So we can replace that. So let's replace that. So you can use any equation you want because these three are 1. These three y. So I want to take the easiest one, which is the first one, I think. So let's do 2x plus 3y, which now is 1, equals 1. So let's just solve that. Subtracting 3, we have 2x equals negative 2, so x equals negative 1 by dividing both sides by 2. So now we have the solution is x equals negative 1 and y equals 1. So this is what we did for the investigation 4D, 4C. Okay?